Alright, today's lesson is on zero and negative exponents. So what do we do when we have an exponent of 0, and what do we do if we end up with negative exponents? Because remember, you can never ever have negative exponents in your answer. So if you get negative exponents, what do we do about them? So the 0 one's pretty easy. 0 exponent, anything to the 0 power like this, anything to the 0 power is going to equal 1. Okay, anything. It doesn't matter what it is. Okay, anything to the 0 power is 1. So in example A, okay, right here, negative 8 to the 0 power is going to equal 1. Okay, and we can even scroll down to do some other examples here. Like number 3. Here's number 3 here. Anything to the 0 power, even 5 to the 0 power equals 1. Okay. Now if it's part of something, like for example if you have something to the 0 power and it's part of something else, you don't even need to put 1. You can just simply cross it out. It's like it doesn't exist. So you could do that. But if it's by itself, like it is in number 3, it would equal 1. That's it. That's 0 exponent. Anything to the 0 power is 1. It's pretty easy to remember that. Negative exponents are a different story. Now, negative exponents, as we zoom in to B here, negative exponents, anytime you have a negative exponent, you need to move it to the other side of the fraction line. You need to make it's called making a reciprocal of it, but basically you're going to draw a fraction line and you just need to move it to the other side. So what this looks like now is, here's your fraction line, but now the 4 is on the bottom. What this does by moving it across the fraction line is it changes your exponent to a positive. Because we can't have negative exponents, this is a solution to getting rid of the negative exponents. Now the exponent is a positive. Since we have a blank on top, we've already learned this, since we have a blank on top, we fill it with a 1. And then we do any sort of simplifying if we can. In this case we can because we know what 4 squared is. 4 squared is 16. And that is your answer. Okay. So if we move down here to do some example problems like number 1, when we have a negative exponent, if there's no fraction line, go ahead and draw one, and then just bring it to the other side. So what this looks like now, here's my fraction line. You now have the 3 on bottom, but by moving across the line, the sign is changed to a positive. Fill the top with a 1 and simplify. 3 to the third is 27. Okay. So let's look at another example here. We'll do 5 and 6. 5 and 6 incorporate what we've learned in the past couple lessons here, where number 5, dealing with this negative exponent should be the last thing that you can do. If you could do anything else before, do it. Don't start moving or drawing the fraction line and then moving it down when you could simplify first. I could simplify this first without having to deal with the negative. Since this is multiplication, my exponents are going to be added, so this becomes 3, 5 plus a negative 4 is 1, and I get 3 to the 1, which is 3. Notice how I didn't even need to deal with the negative exponent because I could simplify first. Same thing goes with number 6. Okay, I can distribute this exponent first, since this is power to a power. I can distribute that exponent first and then deal with the negative. When I distribute the exponent, negative 2 times 3 is 2 to the negative 6. Now I can deal with the negative by bringing it to the bottom. Here's my fraction line. The 2 is now on the bottom, but with a positive exponent. 1 goes on top, and then I simplify. I know what 2 to the 6th is. That's 64. And that's my answer. Okay, so do anything you can, do any work that you can before dealing with the negatives. Don't just start moving things around right away. Okay. Let's go to the next page and look at some more realistic examples that you may actually see on a quiz or a test. Letter A here has a couple things that have negative exponents. Anything that has a negative exponent is going to be moved across the fraction line. Notice that the 5 here does not have a negative exponent, only the y and only the z. So the 5 will not move. It does not have a negative exponent, therefore it does not need to move. So when you draw your fraction line, only the y and only the z is going to come down. So here's my fraction line. The 5 will remain on top with the y and the z coming down, but their exponents changing to a positive. There's nothing I can do to simplify. That is simplified as much as you can. Same thing goes when you have multiple things in parentheses, just like we did before in the previous lesson. You're going to distribute this to both pieces. So this becomes 2 to the negative 3 and x to the negative 3. Both have negative exponents. Therefore, when I draw my fraction line, both will come down. So here's my fraction line. The 2 is on the bottom, but with a positive exponent. The x is on the bottom, but with a positive exponent. Since I have an empty top, I fill it with a 1, and in this case, I can simplify. 2 to the third is 8, so I get 1 over 8x to the third. Okay? That's simple. Well, it's not simple, but that's how you deal with negative exponents. So let's look at some more examples here. 11, actually number 9. With number 9, you notice that the negative exponent's on the bottom. It doesn't matter if the negative exponent is on the top or the negative exponent is on the bottom. Anytime you move it across the fraction line, whether it's top to bottom, okay, top to bottom or bottom to top, is going to change the exponents to a positive. So in this case, when it's on the bottom, just move it up to the top. By crossing the line, so you have 7, and by crossing the line, the exponent now becomes a positive. Here's my fraction line. Just moved it up. Now, in this case, I don't have a bottom anymore. But remember what I told you, you don't need a bottom. I mean, you could put a 1 on the bottom, but you don't need to. Therefore, that is your answer. Again here, dealing with zero exponents. Remember, when it's part of something, you can simply just cross it out. And the only thing that needs to happen is this needs to come up to the top. So you get a 3, here's my fraction line, 3y to the third. Don't need a bottom, so there's my answer. Okay, move on here. We've done those. All these are types of problems we've done. 10, just bring it up. 12, you'll distribute and then bring them down. Number 4, or 14, sorry. Notice how you have this entire set of parentheses to the 0 power. Remember, anything to the 0 power can be crossed out. So all of that gets crossed out when you draw your fraction line. The only thing that needs to change is this needs to come down. So here's my fraction line, y to the positive 2 now, with a 1 on top. Okay. Let's look at, we'll do number 17. Number 17 is as difficult as these problems get, where you have to do multiple steps here. I have to distribute to all of these pieces. Remember, this is not 4 times negative 5. It's not 4 times negative 5. It's 4 to the negative 5th power. Multiplying, I get x to the 20th and y to the 60th. Okay? Notice here that there is only one thing that has a negative exponent. So when I draw my line, the only thing that needs to come down is the thing that has a negative exponent. The x and y both have positive exponents and therefore don't have to move. But this 4 to the negative 5th needs to come down. So what I get is x to the 20th, y to the 60th, over 4 to the positive 5th. And then you can simplify. Okay. Let's see, x to the 20th, y to the 60th, 4 to the 5th. I have to get out a calculator, but that is 4 times 4, 16. Let's see, 32, 64, 128, 256, 512. And that's your answer. Okay, so now we're going to move on to dealing with fractions. Okay, so even we're dealing with negative exponents in fractions. So we talked about this. This was in your bell work this particular day, but this incorporates power to a power. So if we look at number 2, power to a power, since we have this exponent on the outside of the parentheses, using your knowledge on what we learned last time, you would distribute to everything in the parentheses. That includes things that are on the bottom of the fraction. Because this whole thing is inside the parentheses, everything gets distributed. So to here and to here. So what you get on the top is x to the 48, and on the bottom, y to the 24th. They are different letters, okay, x and y, so we can't simplify this any further. Therefore, this is your answer. Okay, so let's look at one that we can simplify. If we look at number 4, even with negative exponents, you still distribute. So you have b to the negative 20 over b to the negative 6. And then we do what we learned the first day. This is division. Okay? When dividing things that have the same base, you subtract your exponents to the bigger side. Since the negative 6 is a bigger number, I'm going to subtract from this side. So it's negative 6 minus negative 20. Negative 6 minus negative 20. Since here's my fraction line. Since the b is bigger on the bottom, it's going to go on the bottom. And negative 6 minus negative 20 is 14. We have an empty top, so I put a 1 there. Okay. And that's the same thing you would do on number 5 as well. Number 6, the problem looks a little different, but these are just overgrown parentheses here. But you're going to distribute to all pieces. Meaning this is not 7 times 3, it's 7 to the third. And a to the third over b to the 6th. The only thing that needs to be done here is just a little bit of simplifying. 7 to the third is 343. Since you have different letters here, these cannot simplify. Therefore, this is your answer. Now let's get into the doozies here. We're going to do 11 and then we'll do 16 and we'll be done. So number 11, okay, I'm going to let you try to do this one on your own. Just remember to distribute to all pieces. Okay? Pause the video, check your answer when you're done. Okay, so after you've distributed, this is what it looks like after you've distributed that 3 to everything in here. This is what it looks like. Okay. Now, we take care of our coefficients first. Okay. Notice that these have different bases. This is like an x and a y. They cannot combine. They have different bases. So the only thing we can do is just simplify what these are. So do 3 to the third and 2 to the third. 3 to the third is 27. I'm going to draw my fraction line. And 2 to the third is 8. Then you look at your m's and your n's. Okay, this is division, so we're going to subtract them to the bigger side. Since the 6 is bigger on the top, the m is going to go on top. I subtract 6 minus 3. That's 3. N's are bigger on the top, so the n goes on top. 12 minus 9 is 3. can't simplify. You cannot simplify this fraction any further. 8 does not go into 27. So this is as simple as it's going to get. Okay. Last problem. I'm going to let you try number 17 number 16 on your own. Pause the video and check your answer once you're done. So here's what you get once you distribute it. Remember that this is not 2 times negative 3. It's not negative 6. This is not 2 times negative 3. It's 2 to the negative third power. Okay. X to the negative ninth, and then y to the 24th. Now the only thing that you need to move are things that have negative exponents. So the y to the 24th, having a positive exponent, doesn't need to move. The only things that need to come down are the 2 and the x. So what this looks like, let me pan over here. What this looks like with my fraction line is y to the 24th will remain on top, but now I have 2 to the positive 3 on the bottom and x to the positive 9. All that's left is a little bit of simplifying. We know what 2 to the third is, so as we calculate this, I have y to the 24th over 8x to the 9th. Okay. There is nothing to simplify, y, x, okay, and an 8, so therefore that is your answer. Any questions, please send me a message on Canvas, or you can come in during AL to get any help with this. Keep in mind that your first quiz is in cycle 4, which is either January 15th or January 16th, depending on when you have me. So make sure you are ready and prepared for that quiz.